Imagine one day you get on a spaceship and travel at a speed close to the speed of light. When you return to Earth, everything has changed. The people you knew are now old. New generations have been born, but you're almost the same as when you left. Crazy, right? This isn't just a science fiction story. This is exactly what Einstein's theory of relativity tells us. Hello, everyone, and welcome back to the Axiom class. It's great to see you again. Let's dive in and start today's lesson. In the early 20th century, Einstein introduced an idea that completely changed how we see space and time. Before him, most people believed time was like a giant universal clock, ticking the same for everyone. But Einstein showed us that time doesn't flow equally for all observers. Time and space can stretch, shrink, and shift depending on speed and conditions. The first surprising fact is that the speed of light is always constant. No matter if you're standing still on Earth or moving on a rocket, if you measure the speed of light, you'll always get the same number, about 300,000 kilometers per second. For that to work, something else has to give. And what changes is time and length. Picture two twins. One stays on Earth, while the other boards a spaceship and travels close to the speed of light. When the traveling twin returns, he finds that his brother has aged a lot, while he himself is almost the same age as before. This phenomenon is called time dilation. The faster you move, the slower time passes for you compared to someone standing still. Now, here's a fascinating question. If you move at the speed of light, do you become invisible? Not exactly. What really happens is that, from the perspective of outside observers, time for you practically stops. To them, it's like you're frozen in a single moment. But inside your spaceship, everything feels normal. So, no, you don't vanish, but something even stranger happens. You start living in a completely different timeline. Another common question: does this mean you can go back to the past? Here, the answer is more complicated. Relativity allows us to travel to the future by moving extremely fast, but going backward into the past has no scientific evidence so far. Some theories talk about wormholes or bending space-time, but these ideas are still hypothetical and come with huge problems. For now, what we know for sure is that going forward is possible in theory, but returning is almost impossible. You might think all of this is just theory, but it's not. These effects have actually been tested. For example, scientists put atomic clocks, which are extremely precise, on airplanes and flew them around the Earth. When compared with identical clocks left on the ground, the flying clocks showed a tiny but measurable difference. Even the GPS system in our phones wouldn't work properly unless it corrected for relativity. So, relativity is not just theory. It's part of our everyday lives. This means Einstein didn't just propose some strange abstract idea. He opened a new window into understanding the universe. A universe where time isn't a river flowing equally for everyone. Time can flow differently for each person, depending on how fast they're moving or what kind of gravitational field they're in. Now imagine if one day we could actually build spaceships that travel close to the speed of light. What would happen? We could take interstellar journeys, see Earth's far future, and maybe even uncover new secrets about the very fabric of space and time. And this is just the tip of the iceberg. There's so much about the universe we still don't know, but relativity already shows us how reality can be completely different from what we expect. If this topic fascinated you and you want to explore more of these mind-bending mysteries of physics, make sure to follow Axiom, and don't forget to like this video, so we can keep diving into the wonders of the cosmos together.